Hello everyone, this video lesson is about the distributive property. It tends to go together in lessons with another concept called combining like terms. I've separated those two concepts into two separate videos, so this one's called 3A, and the video about combining like terms will be video 3B. Once again, I've got a batch of problems for you to try because I'm assuming this is review for you. In this case though, even if it is review and even if you understand it very well, I'm going to recommend you watch this video all the way through because I'm going to show you an application of the distributive property that most students don't seem to realize they could use, and it tends to be very helpful in making some quick estimates. But first, hit the pause button and try to work these 10 problems out. Okay, I'm going to assume that you've worked all of them out and are ready to see the answers. Here they are. And if you need to, hit the pause button and look these answers over, compare them against yours. Meanwhile, I'm going to move forward and I'm going to show you some examples first of where you can use the distributive property. I talked about the idea that I'm going to get to a specific application most students don't know about, but before I do that, let's just talk about the general rules of the distributive property. The factor you're distributing, in this case it's a 2, that case it's an x, that case it's an 8, and lastly here's a y. The factor that you're distributing could be on the left or the right. It could be a number, or it could be a variable, or it could be a combination of the two. It actually could be a number and variable together. No matter what's going on, whether it's left, right, number, or variable, the way to do this is literally to distribute that factor to everything that's inside the parentheses. So it's starting to say both things because those are the only examples we have here, but you could have 3 terms inside parentheses. However many you have, distribute the factor on the outside to all of the terms inside. So the 2 goes to the x and it goes to the 5. Most importantly, notice, or maybe most challengingly, notice what happens with the y. Y times 1, well that's just y. But y times negative y, well this goes back to that video lesson we had a couple of videos ago where we were multiplying a negative x and a positive x. And, or maybe it was a negative 1 and a positive 1, I'm not exactly sure that I remember. At any rate, there's only one negative sign, but there are 2 y's. So you've got one negative sign, 2 y's, multiply the y's first, remember the PEMDAS rules, y times y is y squared, and the negative stays with these guys and it becomes negative y squared. Okay, some basic rules about working with the distributive property. If the factor has a negative sign, then that negative sign has to go with or be multiplied against each term inside the parentheses. So this negative 3 goes to the x and it goes to the 4. You know what, this is going to be a little clearer if I don't show everything at once. It goes to the x and it goes to the 4. Likewise, this negative 4 goes to the y and to the 5. So negative 4 times 5 becomes this negative 20. Negative 4 times y becomes this negative 4y. Perhaps most challengingly, here this negative on the outside. Students often get confused here. Think of this as negative 1. Negative 1 times 6, and that's exactly what they've done here. And negative 1 times negative 3x. Well, negative 1 times 6 gives you that negative 6 you get here. But negative 1 times negative 3x, those negatives cancel and it becomes positive 3x. The last one is actually the most challenging and it's given the least amount of space. Negative 9x times these 2 terms. Well, negative 9x times x. We'll multiply the x's to get x squared. So it's going to be negative 9x squared right here. Negative 9x times negative 1, the negatives cancel and it becomes positive 1 times 9x, or in other words, positive 9x. And this is the answer to D. Hit the pause button if you need to study the answers to A through D. Like before, I'm going to move on. Here are a couple of questions that have been done incorrectly. Actually, I'm going to cover up the left half and just find the right half and just look at the left for now. See if you can figure out what the mistake is. Hit the pause button if you need to, but realize the answer is not 8.8. Okay, I'm going to assume that you've done that. The correct answer, the correct answer is negative 8.8. Why? Because negative 2 times 6.5, that should be negative 13. And negative 2 times negative 2.1, those should have canceled. It should be positive 4.2. So you get negative 13 plus 4.2, and that should give you negative 8.8. How about the one on the right here? Well, in this case, it's a little more complicated because you've got, like before, a typical distributive property setup here, but it's 5 minus these things. Look at how the person who did this worked this one out and see if you can see the mistake they made. Once again, hit the pause button if you need to, and when you come back, I'll show you the answer. Okay, I'm going to assume that you did that. The mistake this person made is that they distributed the negative 4 only to the 3. So negative 4 times 3, that is negative 12. But what about negative 4 times x? That's not x, that's negative 4x. So the answer really ought to be negative 7 minus 4x. Okay, now, as promised, even if you have been working successfully with the distributive property for a long time, you may not be using it this way. And this does help you to make some good, quick estimates. And actually some good, quick calculations. If you had to do 3 times 68 in your head, one way to do it would be to separate out the 68 into two pieces, 60 and 8. Maybe that's easier for you to hold in your head. 3 times 60 plus 3 times 8. 3 times 60, well, that's 180. 3 times 8, well, that's 24. And then 180 plus 24 is 204. Maybe that's easier for you to do than 3 times 68 in your head without pencil and paper. Or an even more relevant example that a lot of students find useful. If I have 5 cases of soda and each one of them costs $4.98, how much am I actually going to be charged? How do I know whether or not I'm getting charged the right price? Well, here's how I would work it out. I would do 5 times $5. Notice how close $4.98 is to $5. It's 2 cents off. It's 2 cents below. So it's going to be minus 5 cases after all, 5 of these 2 cents. So minus 5 times 2 cents. 5 times $5, that's 25 bucks. Minus 5 times 2 cents, 25 bucks minus 2 cents is $24.90. Not so hard actually to do in your head. It might not even be necessary to have pencil and paper at all. Here, take a challenge. Here's a more complicated one. And hit the pause button, and when you come back, I'll show you the answer. Okay, I'm going to assume that you've worked this out, and here you go. The actual answer is $50.57, and let's look at why. You've got 4 of the OJs, they're almost $3. So it's 4 times 3 minus 4 times a penny. You've got 6 of the peanuts, they're almost $4. 6 times 4, but they're 5 cents off, minus 6 times a nickel. And then I think you see how I've set up the rest of this. There are 3 whole dollar prices here, and 3 penny prices subtracted off. Then you just put this all together. 4 times 3 is 12, 6 times 4 is 24, 3 times 5 is 15. All of this may be too much to do in your head, but it's a whole lot faster to do quickly, like on the back of an envelope, than you might be able to do if you had to literally multiply 4 times 2.99 and then 6 times 3.95 and so on. These whole numbers, these whole dollars, minus these pennies, in other words, $51 minus 43 cents, is $50.57. Okay, that's it for the video lesson. Don't hesitate to come in with any questions you have about it, but that's it for the distributive property.